Hi, welcome back. We're going to continue our discussion on the first fundamental theorem of calculus. So let's kind of review a little bit of things about what the fundamental theorem says. Remember, the fundamental theorem says if we're taking the antiderivative from a to b, f prime of x dx, that's just a difference in the values, f of b minus f of a. Now the first example we're going to take a look at today is kind of a big problem for us. Here they're telling us the value at 3 is negative 3. And then they're telling us that the area between 3 and 5 of our derivative function is 19. And they want to find the value at 5. So let's look at this what this kind of means right here. We talked the other day about what the integral means. Remember, if you look at the fundamental theorem, notice this is my change in my y values of my function. So that is really what this is saying. This is the change in the y values of the function f of x. So let's kind of think about it like this. We know that the change in the y values is 19. Well, if I'm starting at negative 3 and I'm changing by 19, what should the value at 5 be? Well, it should be pretty easy to do in our head. Negative 3 plus that 19, and that's going to equal, of course, 16. So, and graphically what that looks like, we saw this as an area problem. Between 3 and 5, Riemann says we can draw a rectangle between 3 and 5 that has an area of 19. And I can even get the height of that rectangle. Remember, to get the height of that rectangle, it's just the area divided by the base, and the base here is 2. So the height of that rectangle is 19 halves. And we had a special name for that. That was called the average value of the function. We'll talk about that a lot later on. So remember, what this is telling us is that this is a change in the y values. In other words, that's delta y. So if I want to solve this using calculus, though, this is what the AP wants to do, is we're going to set up the Ftc, the fundamental theorem. And it says that the area from 3 to 5 of f prime of x dx is going to equal f of 5 minus f of 3. And we saw a problem like this yesterday in our notes. We know that this whole area here is 19, and that's going to equal f of 5 minus f of 3, which we already know is negative 3. So therefore I can just use a little bit of algebra and say the value at 5 is just going to be 16, which is what we said. Remember, this is my change in y values. In other words, as x goes from 3 to 5, our y values are increasing by 19. So if my y value starts at negative 3, so kind of like this, if my y values start at negative 3, and I'm increasing my y values by 19, it's going to put me at 16, which is what we got there. Really good problem. Hope you guys paid attention, because it's a really good explanation right there about the understanding of what the fundamental theorem does for us. Alright, example 2 talks about Merry and Pippin. They have trapped ogres in an almost empty pool, and they decide to flood it by pumping in water. The water is pumped in at a rate. Now remember, they're telling me that this is a rate, which for us means it's a derivative. Okay? And let's keep reading. Gallons per minute, where t is in minutes. If the pool has 1,000 gallons of water after 30 minutes, so they're giving me right here some sort of initial condition. How much water is in at the beginning of it? How much water is in the pool when they started pumping in water? So we want to find out how much water is at the beginning. So after 30 minutes of 1,000 gallons, we want to find out how much is in when we started filling it up. Now, notice though, I'm not looking for a rate, I'm looking for a value. And anytime we want to go from a derivative to a value, we have to use antiderivatives. This is a perfect example of the fundamental theorem. And that's what we're going to take a look, we're going to use here. But before we do that, let's make sure what units our answer will be. To get units, I'm going to take an antiderivative, r of t dt. Well, R of t is in gallons per minute. My change in time, of course, is in minutes. And what's that going to leave me? Yeah, it's going to leave me with the amount of gallons. And I can use that to get my answer. So here we go. Ready? We're going to integrate. So I'm using an antiderivative because remember, I'm going from a derivative, a rate, to a value. So we have to integrate this one. Given the derivative, how do we get the original function? We integrate that. And this is we're going to use R of t dt. Now remember, we started at time equals 0, so we'll put that at the bottom, and we ended after 30 minutes. And if I use my fundamental theorem, the FTC, that's going to equal the value of at 30 minutes minus the amount or value at 0 minutes. And I know all of this. Well, unfortunately, I know the 30 is pretty easy. That's 1,000 minus f of 0. That's what I want to find. But I don't know this. And honestly, I don't know how to integrate that yet. So we use our calculator. So, ready? Oh no, it's hard to see there. There we go. I'll put it over here. Doc B, clear out everything. So I'm going to integrate my function here, R of t. Now you could put the equation in there if you like, or just call it R of t. And if I integrate that one, I like to go to the home screen, menu, calculus. We're looking at an integral from 0 to 30, and I just type in my equation. 3 plus 40 second e, not second e, excuse me, just e to the negative 0.2 t. Now, I'm using Inspire, I can use t. I just have to make sure when I go over here, when I put in my differential, I have to use t as well. And of course, you can use x if you like. If I press enter, it gives me this 289.504. So I put that down, 289.504. Now remember, what is this representing? And I want you to write this down. This is the change in gallons. And it's an increase. So whatever we started with, we've increased by about 300 gallons. So how much did we have to begin with? From here I can solve it. Therefore, f of 0, and if I subtract, this is definitely a calculator question, so if I take that 289 minus 1,000, and I'm going to change my sign because of the negative there, and we should get 710.496 gallons at the beginning. And there's our answer right there. Not too hard to do. Alright, so here's a cool question. This came from an AP test. Of course, I changed it around. Leia was not feeling so well, so Han decided to make her a cup of hot chocolate. The hot chocolate was too hot, so Leia placed it on the counter to cool off. The temperature, always be careful of what they're giving us in terms of the problem. The temperature of the hot chocolate is given in the table below. So at 5 minutes, the temperature is 180 degrees Fahrenheit. At 10 minutes, 160, and so on and so forth. Now look at what they're telling me to do. They want me to integrate from 5 to 20 of t prime of x. This is an FTC problem right here. Okay? Let's look at the units that they're going to give us. Now, take a look. They're giving me t prime of t. This is a rate of change. So this would be degrees Fahrenheit per minute, where the time is going to be minutes. So what is this going to give me? This is going to give me the change in temperature. Therefore, my answer is going to equal a change in temp. How much the temperature increased or how much the temperature decreased by. Now, the mistake people always make is they always say, oh, it's a table, I better use a Riemann sum. Be careful. If I use my FTC, if I set this up, I know exactly what it's going to tell me. So let me go and rewrite this out. T prime of x dx. Well, if I integrate this one using my fundamental theorem, I would get t of 20 minus t of 5. Now notice, I'm looking at the values here. These are my values. So, and they give me the temperatures. At 20, we know it's 100 degrees. And at 5, the temperature is 180 degrees Fahrenheit. And if I subtract them, I just get negative 80 degrees Fahrenheit. So what that tells me, over those 20 minutes, it's changed by roughly 80 degrees Fahrenheit right there. All right, the next question It says, what's the average rate of change over the time interval 12 to 20? All right. Well, to get that, this is what we call an average value. Right here. So I want the temperature change from 20 to 12. Well, if I want to find the average rate of temperature, I have to find the difference in the value. So we're going to use a new formula here today. Okay? I want to find basically the temperature at 20 minus the temperature at 12. If I want to find the average value, I got to find the average rate of change, right? A rock. Remember, this is my A rock. I have to find the temperature at 20 minus the temperature at 12 over 20 minus 12. And this should look familiar to us. At 20, we have 100. At 12, it's 140. And of course, we're going to divide that by 8. And of course, if you simplify that, that gives us negative 5 degrees Fahrenheit per minute. Now, this is another formula for us. Now, this should look a little familiar. Oh, look up here. I can write this as the temperature from 12 to 20 f prime of x dx. We saw that up here, how we wrote our answer. We're just going backwards. And I'm dividing that by 20 minus 12. This right here is what we call the average value formula. We're going to talk a lot about that later on next week, okay? Anyways, go on to part 2. We'll take a look at some more examples. And in part 3, I'll work some problems with you again. That was fun the other day. Bye.